I am warm right now due to convection, and the sunlight is coming into my room and heating it up through radiation. And yeah, I'm warming up my chair right now through conduction. So I asked you to look at convection, or radiation last time we talked. So conduction, convection, radiation. Let's say it together. Conduction, convection, radiation. Say it again. Conduction, convection, radiation. We're going to look at some examples and some pictures of conduction, convection, and radiation, and we'll see how well you guys did. You can pause it as you go. So really you need to listen to the words carefully and consider the situation and choose the best form of energy transfer you think is happening in the picture. We'll pause it and then see how well you do. So this one is a person warming their hands over a radiator. What do you think it is? Did you say convection? Because you would be right. The heat is rising and that person has their hand in the rising heat. Remember, convection happens with a gas. All right, let's look at number 2. Eggs cooking in a frying pan. Do you think it's conduction, convection, or radiation? Did you say conduction? If you did, you are right because this is direct contact between the egg and the frying pan. That matter has direct contact. All right, our next picture is a snowman melting in the sun. Did you say radiation? If you did, gold star for you. All right, here we go. Water boiling in a kettle. So it's talking about the water and it's boiling. Did you say convection? Because if you did, that would be right. Convection takes place in a fluid and water is a fluid, right? So convection is taking place in the fluid here. What's this fluid? It's the air, right? Okay, number 5. Warmth from the fireplace is circulating through the house. Conduction, convection, or radiation? It is convection. Now, it is circulating throughout the house. It's not talking about the guy getting heat from sitting next to the fireplace. It's circulating throughout the house, so it's heating the house with air, which is a fluid, which makes it convection. All right, the tongue freezing to a metal pole. You guys have all tried this, right? Sticking your tongue on a cold pole, right? Just kidding, you haven't. But it's in a very famous movie. Okay, what do you think it is? Conduction, convection, or radiation? It is conduction. And why is it conduction? Because there's direct contact between that tongue and the pole. Whenever there's direct contact, it's conduction. Okay, here we go. Number 7. A newt boiling in a hot cauldron. So in a hot cauldron and there's boiling going on. There's a fluid there. Convection. Remember that pot's heating up here and there's a convection current going around in that pan, in that pot. Number 8, ice melting on a hot plate. What is it? Conduction, convection, or radiation? It is conduction. Why? There's direct contact between that ice and the hot plate. All right, let's try a couple of more. All right, I'm not going to give you as long, so you can just think about these if you want, okay? You don't have to write them down, just put them in your head. Freezing outside on a cold day. This is convection. It's a cold day. This person is outside. It's air that's making them lose heat. Steam piping out of a teapot. Steam, also a fluid, right? So it's convection. Burning your hand on a hot pan. This person is touching the pan, so that makes it conduction. All right, ice cubes keeping lemonade cool. This one is kind of tricky. If you say that the ice cube is like touching the water, then that would be conduction, but because water is involved, you have a fluid, and so it is convection. Laying out in the sun, heat's transferred by light. This is a new one, radiation. Can you think of anything else that uses radiation to cook? If you guessed a microwave, that would be something else. Yep. All right, roasting marshmallows over a fire. So the marshmallow is over the fire, so the light's not cooking it. The gas is, and because gas is a fluid, we have convection. Making toast in a toaster. This one's kind of tricky because the toaster kind of glows and lights up, but it actually warms the air. And so the air is what's actually making the toast, so you have convection. But if you chose radiation because the light from the glowing wires, if you thought that did the cooking, I guess I could let that one go. All right, heating a kettle on a hot furnace. So the kettle is actually making direct contact, so this is conduction. Hopefully you did pretty well. All right, if not, you need to go back and read your notes and then go back and review your resource documents. Today, our learning target for today's lesson is, I understand that kinetic energy of particles and temperature are related. Our first important term is kinetic energy. Say it with me. Kinetic energy. It's the energy a substance or object has due to its motion. Kinetic means moving, right? Okay, thermal energy. Say it with me. Thermal energy. It's the total amount of kinetic energy contained in all the particles of a substance. So here's some notes for you. All matter is made out of particles, and these particles are in constant motion. So let me ask you this. Have you ever been to the ocean or a lake where there were waves? If somebody threw a water balloon at you, just a water balloon, and it popped on you, or they threw a bucket of water on you, not much would happen, right? But if you had a great big wave from an ocean or a lake, so more matter, pushing at you, you would definitely fall over or lose your balance. So much more energy in more massive items, just because there's more particles. So I'm going to ask you to watch a video today with Bill Nye, and then I'm going to ask you to complete your notebook today. So here is what you're going to do. This is the question I want you to think about. A bottle of water is 70 degrees Fahrenheit. A bathtub is 70 degrees Fahrenheit, so the same temperature. Both are full, so small bottle of water, giant bathtub. Which has more thermal energy and why? I want you to write your answer here. Use the words kinetic energy and thermal energy to explain why an object you touch feels cold. And I'd like you to put your answer here. Here's a hint. Remember when I asked you to use your hand and put it on your desk? Your hand has mass, your desk has mass. They're touching each other. Heat is moving from one thing to the other. You do the rest of the work. All right, have a fantastic day. See you soon.